And the final thing I'm going to talk about is the histogram. And histograms are good for when we're looking at continuous data sets. And we're interested in looking at the distribution of these measurements as a frequency. And so you're dividing all your measurements into bins or groups. So I'll show you what I mean. So here's a data set I stole from Wikipedia. So these are heights in feet of black cherry trees. And so here I've listed all my different measurements. So I've looked at the heights of these different trees, and and these are the heights in feet, which we probably wouldn't do, but this is what the example on Wikipedia. We'd probably use meters, but why not? Yeah, we can use feet for this once. And so here I've listed them in increasing size order. So there are 31 measurements in total, and it goes from just over 60 feet to just under 90 feet. And so what I want to do is to draw a graph with my x-axis being different intervals and my y-axis being frequency. So how can we divide these up? So a good general rule of thumb for doing our intervals, which I suggest you start. We should use our common sense, but let's just start by doing this. So number of intervals or bins, normally it's the square root of the number of things we've measured. So here it would be roughly, it can't be exactly, the square root of 31 because I've measured the heights of 31 trees, and that happens to be 5.5 something. So what would be so we just have to use our common sense and look at how we want to divide them up. So what I've decided to do is divide every 5 feet. So here we've got all the trees that are between 60 and 65. So in fact 64.9. And here we've got everything between 65 and 69.9, sorry. Here between 70 and 74.9. From 75 to 9.9. So we've got every 5 feet. We're grouping together all the different trees between 65 and 70, for example, in this. And here we've got 75 to 79.9, or we could say greater than 75. Alright, so then we have to count up the number of examples in each one. So this is 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. I've made a mistake here. What am I playing at? What am I doing? Yeah, so here we've got another. So we've got 80 to 84.9, and here we've got 85 to 89.9, or greater than 85. Excuse me. So in this category we've got 1, 2, 3, 4, 5, and in this category we have 2. And then I can make a graph that, so it's basically a bar chart. So let me show. So here's the one I stole from Wikipedia. So here on our y-axis we have the frequency. And on our x-axis we have the different intervals. So here, this is all the trees between 60 and 65 feet, and there are 1, 2, 3 of them, and so on. So we can see this gives us an idea of the general distribution of our data. Now we could have plotted all of these as individual points on a graph, but this is sometimes more informative if we're looking at the general distribution of our measurements. And here it's important to note that there's no gap in between the different bars. So that's how you can tell easily between the normal bar chart and a histogram. So we've got the frequency, or the number or the percentage on the y-axis, and the different intervals along the x-axis. So it's a way of grouping together different continuous measurements and kind of summarizing that data and the general distribution of it.